Whoops. Okay. Hello. Today we'll be talking about binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. I think that's kind of self-explanatory. You just want to return, for one level. So basically, you can look at this as level 0 or 1, depending. So we'll just do 1 because that's how we count from like 1 up, 1 and level 2 and level 3. Another thing to notice is that you want to skip the nulls or none. So like right here, you don't want actually anything, like you don't want to account for those. So with that being said, we'll start the solution. The base case would be if root is none, then just return an empty list, because as you can see, that's what we want, and there's nothing for us to handle if it's completely empty anyways, so we can just do that as a initial base case. Here we're going to initialize a queue, and we're going to queue.append root, because we know here it is not none, so there has to be something at root. So we're able to append it, and from here on, we're just going to build out our solution. So it could either end up being something like this or being something completely complex like that. So res is equal to this, which is just all of our results. While the length of queue does not equal to 0, which means we have something that we need to parse. So after we finish this one, we're going to see that we have 2 nodes here. So after we finish handling this, we're going to see that we have 2 more nodes to handle here. And after we finish handling 7, because we're doing left to right? After we're done handling 7, there's nothing else for us to handle. So this will just exit out by itself, essentially. So I'm going to do a length variable, which just states, so in our first iteration, we'll have just root, right? So the length would be 1. And so since it's not equal to 0, we'll enter our current case. And then, so I want to get an initial, reading of what the length is, because that just means after we're done handling one level, we will know how many nodes that we have to handle for the next level, because we want to break them up into like in their own lists or arrays in order to represent the binary tree in level order traversal. So we need to get the length so that we know where to stop for that current level, like the list representation, and so we can add it to the result list, and then we keep building upon it like that. And so I'm just going to call the list where we hold the nodes of our level called level, just so we have them all in one place, and then we can add them into the result list per every time we finish handling one level. For I in range of length, basically this just allows us to go through every node on the level. We could also do this with a while loop, but since it's always going to be definite, you typically only use a while loop when you don't know like how long it might keep going for. But since we know like there's a definite answer for this, because it's just whatever the length of our queue is, doing a for loop makes it easier to read, probably easier to handle, because you don't have to remember to increment your counter or whatever variable you use at the very end of the loop or at the beginning, depending on wherever you want to increment it. And yeah, so for the nodes in the level we want to handle for it, right? So we're going to do node equals a queue.pop left, because we want to pop it off from the front, right? Because we want to go from left to right. And when you append, it appends onto the right side of the array and pushes, and it just builds out from like left to right, right? So obviously we want to pop off from the left first. And because if we do pop, I'm not too certain, but it might pop off from the very end, and that's like not the order we want to handle it in. So that's what we're going to do. And then level.append, we're going to put the value of the node into our level list. And then now we're going to determine whether or not we have nodes to put into the next level, in a sense. Even though they all go into the same queue, we already calculated the length, so we won't handle for it in this level, right? So in the very beginning at 3, we have 2 nodes here, right? So obviously we want to put 9 and 20, or like those nodes, into our array. But if we go to 9, so now let's just imagine we're on the next iteration, like we're handling for the next level now, for the 9 and 20 level. When we're handling for node 9, we look at left and we're like, hey, there's no nodes. I guess instinctually you might want to put it in, but the thing is, if you have null and then you handle for it, or none, and you handle for it in this, if you have like a whole level of nuns, like after 15 and 7, because if you handle for nuns in 9 and 20, you'll still get the 15 and 7, which is fine, right? But the thing is, if you handle for nuns, once you handle this level, you're going to get 4 nuns, because left, right for 15, left, right for 7, which is 4, right? Then you'll create a new level list here, which you don't want, because then you'll end up having this answer. Let me just copy it. You'll end up having this answer, but then you're going to have a comma this, right? But that doesn't match up with the answer, so you actually get it wrong. So yeah, you actually want to handle for it when you're adding the nodes into the level, into the queue. You want to handle for that here, so that you don't run into that problem later on. So if node.left is not none, then we want to append it, right? So we'll do q.append node.left, and it's the same thing here. If node.right is not none, then you do q.append node.right. And then from here, after you go through all of the length, you handle for the value being appended into the level list here. You handle for whether or not you want to add the node into the queue. You've basically done all you need to do for that level, except for after you handle for those, you want to obviously append that level to the result list, right? So because you obviously want that as part of your answer, and so it'll come back up here, and then it'll see if there's any nodes that it has to handle, and if not, we'll just go ahead and return result here. And yeah, the solution works. And yeah, thank you for watching.